Hey guys, it's Eddie the Magic Monk. Today I'm going to try and help you guys understand normal distribution. I'm just going to stick to the very basics and get you guys working on things as fast as possible, and hopefully you guys will be able to do some stuff with this at the end of the tutorial. So the first thing I want to do is give you guys a situation and draw a graph. So all normal distribution problems will usually be presented to you in a context like this. The waist measurement of 35-year-old men in Australia is normally distributed with a mean of 100 centimeters and a standard deviation of 10 centimeters. So what does that mean? So let's draw a quick graph to show you guys. So I have drawn what we call a normal distribution curve, and in the question that we're talking about, the population is men in Australia, and the mean of this population of 100 centimeters will be straight down the middle of the bell curve. Okay, so the mean occurs in the middle. So the theory behind normal distribution is that most people, well, a lot of people, the most amount of people is going to have a measurement around the mean. Okay, that's why the middle point is the highest. The actual frequency, we don't know what it is, but it doesn't matter because we're comparing the probability to getting other getting other measurements. So 100 centimeters is the most common, okay, and around 100 centimeters, a lot of people will be in this area. And then where it says standard deviation of 10 centimeters, that just means that on the x-axis, we're going to go up and down in units of 10. So we'll have 110 centimeters here, 120 centimeters, and then going back, we'll have 90 centimeters, 80 centimeters, 70, 110, 120, 130, and so on. And as you can see, the further you are from the mean, the less chance of finding people with that waist measurement. So you can see here that there's going to be a lot less people with around 90 centimeters of waist measurement. Okay, myself, I'm about here. I'm at about 104 right now, so it's quite common for people to have my waist measurement. Quite a few people, but a lot bigger than that, 130, there's not that many people with that sort of waist. So that's basically what normal distribution is. Now let's do a problem with that. So a question we could do would be something like this. Find the percentage of 35-year-old Australian men whose waist is in the range of 90 centimeters to 100 centimeters. So basically, we want to know what is the percentage or what is the probability of finding, out of all the 35-year-old men, if you find a random person, what is the probability of them being within this area between 90 to 100 centimeters? So that requires us to find out a little bit more about the normal distribution, which I will write out for you guys right now. So this is some dot points that you need to remember for all normal distributions. Approximately 68.3% are within one standard deviation from the mean. So what does that mean? So the mean is the middle here, right? 100 centimeters is the mean, okay, with this symbol. That's a symbol for the mean, population mean. So within one standard deviation. Now remember how we said a standard deviation is 10 centimeters. So that means that 110 would be one standard deviation away from the mean. 90 centimeters would be -1. So again, that's one standard deviation from the mean. Okay, and then this would be 2 standard deviations from the mean. So from here to here, that would be 2. From here to here would be 3 standard deviations, and so on. So between 1 and -1 standard deviation, the population will have 68.3% that lie in this area. So 68.3%. So this highlighted area, this area that I've just highlighted, is 68.3%. Right? Obviously, the whole thing is 100%, and that little bit is just 68.3%. So what is the question? The question is between 90 centimeters to 100 centimeters. So that's the bit in yellow. So I'll do that again, but in a yellow color. So this little bit, right? What is the area? What is the percentage of that? So the percentage is going to be 68.3 divided by 2. So it's just 68.3 divided by 2, which is 34.15%. Okay, so let's give you guys another question. Find the percentage of these 35-year-old Australian men whose waist is between 110 and 120. So let's go back to our curve. So where's 110? 110 is here. 120 is here. So we want this little bit. So how will we get the pink area? Well, in order to get the pink area, we need to look at the second fact. Approximately 95.5% is within 2 standard deviations from the mean. So on this curve, basically from let me choose another better color. From here, which is 2 standard deviation from the mean, and here, so that's 1 standard deviation. 110 is 1 standard deviation. 120 is 2 standard deviation. So 90 is -1, 80 is -2 standard deviations from the mean. So within 2 standard deviations from the mean, so this whole orange area, orange or pink or whatever color you call this area here is 95.5%. Okay. So that's what we're going to start with. We're going to start with 95.5%. We're going to write that down. Now, because we want the pink area, the first thing we're going to do is half the 95.5%. So I'm going to halve that. So I'm going to get this, I'm going to halve that to get just the right hand side. Okay, I'm going to slowly get to the destination. So to get this purple bluish area, we're going to divide 95.5 by 2, and that'll give us 47.75%. Okay, now remember when I told you guys that this bluish area here, this white area between the mean and 1 standard deviation, that part here was 34.15%. So this part is 34.15. So if we take the white part away from the blue part, from the purple part, then we will have this bit remaining, which is the answer that we want. So we're just going to go 47.75, take 34.15, and that's going to give us the answer. So what's the answer here? 13.6%. Okay, I hope you guys understand a little bit about the normal distribution now. Basically, it's just saying that you get a bell-shaped curve, which is symmetrical. So the right-hand side is exactly identical to the left-hand side. And around the middle, the chance of you being in the middle is a lot higher than the chance of you being somewhere towards the each end on the bell curve. Okay, thanks for watching, guys. See you next time.